I'm in Sommerville, and this is the first of two short videos where I'm going to introduce software engineering and explain why software engineering is important. In this video, I'm going to introduce software engineering by looking at 10 key questions where the answers tell you what software engineering is all about. Let's start with a very fundamental question. What is software? Well, software is a computer program and its associated documentation. But that computer program may be part of a system, so there are several programs within that system, and the documentation is important. When we're doing software engineering, we're not just writing a program, we're also creating the documents and the other information around that, which we need to use that over a period of time. Software products can be of two kinds. We can have off-the-shelf products or apps, which you're all familiar with, or we can have custom software where a customer specifies exactly what they want and it's built to that specification. Now, what do we mean by good software? Good software is what we're trying to engineer. Well, good software should do what the customer wants, it should deliver the functionality they want and at a reasonable level of performance. It should be usable, maintainable and reliable. Turning now to software engineering. What is software engineering? Software engineering is an engineering discipline that is concerned with all aspects of software production, not just coding, but everything from understanding what the user needs to maintaining that software over its lifetime. We talk about engineering to mean a systematic and disciplined and managed approach to the production of software. What are the fundamental software engineering activities? Well, there are 4 activities that are always part of professional software engineering. Software specification, what's the software supposed to do? Software design, what's the organization of the software? Implementation and testing, creating the program and testing that. And software evolution or maintenance, maintaining that software over its lifetime to ensure it remains useful. What's the difference between software engineering and computer science? Software engineering is obviously often part of a more general computer science course. Well, fundamentally, computer science is about the theory of software, whereas software engineering is about the practice, it's about the building of software. And it happens that sometimes the theory and the practice don't exactly match. We usually talk about software systems, so what's the difference between software and systems engineering? Well, systems engineering is concerned with all aspects of a system, the hardware, the software, the user processes that are part of that system. Software engineering is a more focused activity, it's really only focused on the software, but obviously it is closely associated and integrated with the systems engineering process. And increasingly, as systems have more and more software, there's much less of a distinction between these activities. What are the key challenges facing software engineering in the 21st century? Well, I think there's 3 challenges. Firstly, there's coping with increasing diversity. Software is in all sorts of devices, from smart watches up to space stations. We need to be able to understand the characteristics of the device and the computer that we're using to create the most appropriate software for that. Another challenge is the challenge of responsiveness or delivering software more quickly, because businesses and people want things to happen quickly. They don't want to wait several years for their software. And finally, delivering trustworthy software. Software that we can trust, that will be reliable, that will be resilient, that will be able to counter external cyber attack. What are the costs of software engineering? This is a hard question to answer because it varies quite dramatically for all sorts of systems. If we're building a system that's a critical system in an aircraft, it's going to cost an awful lot more per line of code than if we're building an app that's offered for free in the iTunes or Android store. But roughly, we can say that for professional software, 60% of the costs are development costs and 40% of the costs are the costs of keeping that software useful, updating it as things change so that it remains useful for the buyer of that software. A very common question is, what are the best software engineering techniques and methods? And the answer to that is quite simple. There's no such thing as the best method. Because of the great diversity of different types of software, from computer games to embedded software in a watch, we need to use different techniques for these different kinds of software. And organisations developing the software will use and choose these techniques appropriate to their level of expertise and the kind of software that they're developing. Finally, what difference has the web made to software engineering? Fundamentally, the difference the web has made is that it has allowed us to develop and deliver software in a new way. We can deliver software as services rather than as systems that are installed on a user's own computer, and we can access these services remotely. It allows us to build a new kind of distributed system to deliver the functionality that the user needs. Because of the demands of the web and the need to build highly distributed systems, this has led to advances in software engineering, new ways of reusing software, a new programming language and development techniques that can be used. So these are the 10 key questions of software engineering. In my next video, I'm going to explain why software engineering is important in the 21st century.